This is a PowerPoint introduction to algebra. This PowerPoint has been created primarily for pre-algebra. However, it's a great review for a student who's getting ready to start Algebra 1, who perhaps took a semester off, or maybe didn't do any math over the summer, maybe you forgot a few things you learned in pre-algebra. So this would be a good little review for Algebra 1. This PowerPoint is going to go over some important definitions for beginning algebra, and it will have another video that's going to have some problems, more examples for you. So what is algebra? Algebra is a part of mathematics in which letters and symbols are used to represent numbers and quantities in formulas and equations. So basically, to simplify that, we use letters to represent numbers. And we're solving formulas and equations, so different formulas and various equations we'll talk a lot about. We're solving those to figure out what the letter really represents. So we'll talk about that as we go a little bit further. In algebra, we have a variable, which is usually a letter. It could be an X, a Y, a Z, any letter. It could be any letter. A coefficient is the number that's in front of the variable. That's a coefficient, that's a variable. We have constants. We call some of just our regular numbers constants. We put these together, these different terms, and that makes an expression. And if you have an equal sign here, then we actually have an equation. So we'll talk a lot about solving equations later on when we get a little further into algebra. Kind of a difference between arithmetic and algebra here. In arithmetic, we would say 2 dimes plus 1 nickel plus 3 pennies. And we already know from basic arithmetic that a dime is 10 cents, a nickel is 5 cents, and a penny's 1 cent. So we can figure that out pretty easily. In algebra, we would just not fill out all of the dimes, nickels, and pennies because they're unknowns at this point for us. So we would say 2 D's plus 1 N plus 3 P's. And if we wanted to solve that, we would have to add a little more to that. But those are expressions. That's an algebraic expression, 2D plus 1N plus 3P. If we want to say the length is 4 times the width, we can write it L for length equals 4 times W for width. And that would be the length equals 4 times the width, which is what we want. Length is 4 times the width. So we'll spend a lot of time working some problems about how do we word things in algebra. That's very important. X in this problem is the symbol for multiplication. However, you're going to find as we go into algebra, you will very seldom see an X for multiplication anymore, because a lot of times X will be used as a variable. But when we see multiplication right now, we'll see like 4 multiplied by W would not be written like we would normally write it. Normally we would write 4 times W, but we won't write that anymore because that's really confusing, because that could be 4xW with x being a variable, and you really don't know that. So you won't see that written that way. You'll see 4 with W in parentheses. That would mean 4 times W. Or you would see 4W with no parentheses. You don't have to have a parenthesis. That would mean 4W. Or you could see 4 with a dot between them and a W. That would be 4 times W. But normally, you're going to see them like just the 4W. The 4 will be the coefficient here, and the W the variable. 4 times W is 4W. That's what that means. A term could simply be a constant. So a term could just be a number. A term could be just a variable, and here's examples of those. A term could be a coefficient with a variable, like 3x, 2i, that's considered a term. A term could be the product of two or more variables. An expression is made up of one or more terms. So the following expression has two terms. 3x, that's considered a term, minus 4y. 4y is considered a term. So that expression has two terms. If we put an equal sign here and put something beside it, we could call it an equation. But since we don't have an equal sign and we don't have really anything to solve for, we're just saying this is an expression right here. And later we'll talk about simplifying expressions. This expression has three terms down here at the bottom, 4 plus 2x plus 6y. And that would be an expression that has three terms. And later we'll learn how to simplify these and put these in the right order. An algebraic expression containing a single term or a sum or difference of terms is called a polynomial. You'll hear that word a lot, polynomial. A polynomial has no variables in the denominator. So we'll have fractions later on, and you'll see that there's no variable in the denominator of a polynomial. Okay? A polynomial of one term is called a monomial, mono meaning one. Two terms is a binomial, bi means two, and three terms is a trinomial. Tri means three. So monomial, binomial, and trinomial. Kind of a tongue twister there. So 2x, if you have a 2x, that's just one term. That would be a monomial. 2x minus 3y, there's two terms there, so that would be a binomial. And 4a plus 2b minus 3c, that's a trinomial because there's three terms there. And over here's a few more examples of those. A little review of exponents. Exponents work in algebra very similar to the way they worked before, except instead of just applying them to numbers, we can apply them down here to the variables as well. So of course, as a little review, the base in this problem right here is 2. The exponent or index is a 4. And of course, that's 2 to the 4th power is the way we read that. And that's 2 times 2 times 2 times 2. Okay. Well, when you come down here in this example down here where this x is raised to the 3rd power, we can say that's x cubed. If it's an x to the 2nd power, we say it's x squared, but x to the 3rd power is x cubed. So here is x cubed, which is x times x times x, or x all in parentheses, and you wouldn't even have to have, you could just put three x's together, and that would mean x times x times x. Like I told you before, multiplication now we don't have to have these dots in between. We don't have to have an x for multiplication symbol. We can just put the variables side by side, and that's understood to be multiplication. X to the 4th power, of course, would be x times x times x times x. So you can see the exponents in algebra can be applied to the variables, just like exponents up here that you learned years ago can be applied just to the base number there. These are some examples where we can see how the variables work. If you have y times y times y, that's the same as y cubed. Here, a raised to the 4th power would be a times a times a times a. Here we have two x's and two y's. So we can say that's x squared and y squared. So that's x squared times y squared. Here we have 9 times 9. Now that 9 in parentheses, with that 9 in parentheses, that means 9 times 9. And then x, that's x times x times x times y times y. Well, we can combine these, and we're going to talk about combining like terms in a minute, but we can combine these three x's to say x cubed. And these two y's to go to y squared, because that means y times y. And then the 9's, there's two 9's, so that would be 9 squared. Now you may automatically know that's 81, but for now, just to learning how to put these variables and coefficients together with exponents. That's how we do that. Okay, let's talk about like terms. A like term has the same letter variables, which are raised to the exact same powers. Only the first number coefficients of the terms are different. Now, the coefficients may be the same, but they can be different. For example, 3a and 2a are like terms because although they have different coefficient numbers, they have the exact same letter a in them. So a is their variable, so they're considered alike. So if you look down here in these examples at the bottom, the numbers in front of the letters can be different. That's your coefficients. They can be different, but the letters have to be the same to be considered a like term. And if there's an exponent, the exponents have to be the same. So d squared y, they're the same, so they're considered like terms. Here you have a 3 in front of the d squared y. We have a 12 in front of the d squared y. Here we have a 2. That's actually you can say it's minus 2, but that's a negative 2, but it's still d squared y. So all of these are considered like terms. And if there's no coefficient in front of a variable, it's considered 1. It's understood to be 1. Here at the bottom, we see these BHs. They are like terms. BH, 4BH, negative 5BH, or just negative BH, because that would be understood to be a negative 1. In front of that BH. All of those are considered like terms. One thing that we will be doing in our assignments early on in algebra is learning to recognize these like terms and learning how to combine these like terms. So here's an example. We've got 4w plus 3 plus 2w minus 1. Well, what's alike in here? Well, the 4w and the 2w are the same. So here you can see in this step here that they've been turned blue. And then the 3 does not have a variable and the 1 does not have a variable. So they're considered like terms. So you can combine this 4w plus 2w. You can add the coefficients together and get 6w. Here you can take the 3 and the negative 1 or the minus 1, and we'll talk a little more about that later on. But 3 minus 1 is 2, of course. So you can simplify this expression down to 6w plus 2 because we've combined our variable terms and we've combined our constants, which these numbers do not have variables. So you can combine those together and end up with 6w plus 2. Let's look at one more example like that. Here we have 3a cubed minus 10ab squared plus a cubed minus ab squared minus 7. So we've got a lot of things going on here, but the main thing we want to look at is our variables. Where are our variables the same? Well, here we have an a cubed, and here we have an a cubed. So those two, I'm going to try to change this to a pen and kind of underline these for you. It may help a little bit. Oh, I can't see what I'm doing here. That color does not show up too good. Let's try another color here. There we go. So that a cubed there and this a cubed here are the same. So we can combine those, and you can see that's what they kind of did here. They just turned them blue down here in this step for you on the next step. We can see that our ab squared right here is the same. There's another ab squared there, so we can combine those together. And then that just leaves this 7 over here by itself. So here on this step, you can see they took this this 2a cubed, the 2a cubed, they brought it down here, they turned it blue for you, and they took the 3a cubed and they made it blue. They made this 10ab squared green to show you that it's the same as this ab squared here. So now we're going to combine these terms together. You take the a cubed here and this a cubed here, and you can put the 2a cubed and 3a cubed together. And when you add those together, you have 5a cubed. You can just add your coefficients. Okay. When you have your ab squared and your ab squared here, you bring both of those down because those are like terms. Now remember, if there's nothing in front of the ab squared, it's understood to be 1. So they went ahead and put a 1 right here for you so you can understand that. So now you've got a negative, you've got a 10ab squared and an ab squared. And this kind of is another step that we're not really talking about yet. We'll talk about it a little more later. But this is actually we call this a negative 10 ab squared, and this is a negative 1 ab squared because you got the minus signs. And when you combine those together, you get negative, there's a negative there, 11 ab squared. If you don't quite understand that yet, don't worry about it. We'll get to that. And then you have a minus 7, and that's how we end up with that. But basically, when you have this negative 10ab and you subtract 1ab from it, when you subtract a negative from already a negative number, you end up with a negative 11 in this case. And like I say, that would, if you've already had pre-algebra, you'll understand that. If you're just taking pre-algebra for the first time, that's something we will practice later on. What I want you to really see here is how you're combining the like